All right, welcome to the latest edition of Science Quarter. My name is Justin White and we're here at Imagination Station's Science and History Museum. Today we're going to be doing experiments that deal with chemical reactions and exploring if we have physical or if we have chemical change. Now first we need to talk about do we change as far as do we have a physical or chemical change. Physical change is whenever you take an object like our paper towel here and all you do is you change the physical appearance of it. So all I did is I just crumpled it up. The chemical composition of our paper towel is still the exact same. However, if I were to go and set our paper towel on fire, we are creating a chemical reaction. Now by creating this chemical reaction, what we're doing is we're actually changing the chemical composition of our paper towel, since we're now creating smoke as well as we're turning it into ash. So one of the important things to remember whenever it comes to physical versus chemical change is that with physical change, you can get your object still the same chemically and molecularly. However, with a chemical change, you can't get that object back. That object is gone forever, and the molecules that make up that object are permanently changed, as well as the chemicals that make up that object. Now, when it comes to chemical reactions, one of the things you want to look for is smell. If you smell an odor coming from a mixture, then you know you definitely have a chemical reaction. You can look for bubbles. You can look for look for a sound like fizzing or popping, and you can also look for a color change as well. And those are just a few of the things you want to look for whenever it comes to chemical change. Now, on top of that, we're also going to be exploring the types of reactions that we get from a chemical change, if that's in fact what we have during our experiment. Now, there's two types to look out for. There's endothermic and exothermic. Endothermic reactions, whenever they take place, they pull energy inwards, which is going to give that composition a cold feel to it. Now, if you feel heat coming off of your reaction, then that's going to be a exothermic reaction, in which exothermic releases energy outwards, and you feel that in the form of heat. So we're going to be experimenting with that today. Now, our experiment today, we're going to be using two different types of matter, and we're actually going to create a third type of matter. Our solid that we're going to be using is going to be magnesium oxide, which is a metallic substance that actually looks like pepper or gunpowder, as some of the reactions I've received from students. And then we're also going to be using vinegar, something you probably already have in your pantry at home. Vinegar you can use for quite a different variety of science experiments. And then what we're going to do is we're going to mix the two together, see what type of change we have, and then if we have a gas, which is one of the things you want to look for in chemical reactions, our chemical change is you want to, we're going to test that to see what type of gas we have. So the first thing we're going to do is we're going to measure out our solid. So on our scale, we're going to turn that on, and we already have our beaker on the scale. What you want to do is you want to zero out your weight, just so you can make sure you get an accurate measurement. So we're going to hit the tar button, and that's going to give us a 0 on there. So it's like we don't have anything on the scale at all. And then I'm going to start to measure out our magnesium oxide, and I want to get to about 20 grams. So we're at 20 right on the dot. And during this experiment, it's very important you also make sure that you close the lid on your magnesium oxide and then take it away from your experiment. Now, when it comes to measuring what we're going to, our liquid, which is vinegar, we're going to use our graduated cylinder, and we're going to measure out 150 milliliters of vinegar. And so 150 milliliters is going to be about halfway through the graduated cylinder. And the important thing when doing chemistry experiments like this is you want to make sure you have accurate measurements, because if you don't, then there's all sorts of possibilities as far as what could actually happen, and you could not get the desired result. For those of you who like to bake, it's almost the same thing with baking, which is kind of like chemistry in itself, where you need to make sure your ingredients are very accurate, so you can get the desired texture or the desired size of your whatever you're baking. So the next thing we're going to going to do is we're going to mix our two substances together. So first of all, I'm going to dump our magnesium oxide into a plastic bag. I'm going to close it up just a little bit. And then I'm going to very quickly pour in our vinegar. Now at first you don't see much of a reaction, but whenever you shake up the bag, you'll start to hear fizzing, you'll see bubbling. The liquid will actually start to boil because of the reaction with the magnesium oxide, and you actually will see steam start to rise, and you see condensation build up on the sides of the bags. So that right there, all those indicators should tell you that we have a chemical change going on within our bag. Now, one of the other things you'll notice is that our bag now has a gas built up in it. So what we want to do is we want to figure out what type of gas we have. And one of the best ways to do this is to test it against fire. Now, this is something you definitely should not do at home. I highly recommend you not test out a mystery gas at home with fire because that can end very badly for you and everybody around you. But I know what's in this bag, so we're going to be able to do this pretty safely. So the next thing I need is a volunteer to come up. And what we're going to do is we're going to throw on our gloves and safety goggles, because whenever you're doing science experiments, no matter how risky they can be, you'll make sure you want to always practice good lab safety. All right, and our volunteer is going to hold a popsicle stick. We're going to light our popsicle stick. In order to have fire, some of the things that you need a fuel source, which is our popsicle stick itself. You also need oxygen, and then you need a spark, which is our lighter. All right, so now we're going to test our gas. All right. Get a good grip on it. And in 3, 2, and make sure you hold on to it. 1. And you can see just how hot that fire was because our bag is almost melted through. And because we had that explosion, I can tell you that we have hydrogen gas. Now, hydrogen gas is very flammable. It's actually incredibly light too, almost like helium, to the point where you can actually fill up balloons and the balloons will float if they have hydrogen gas in them. Now, hydrogen, especially from about the 1850s on into the early 20th century, was actually used in things such as blimps and especially zeppelins. And one of the most famous cases of disasters involving hydrogen gas is the Hindenburg, which happened in 1937 in New Jersey, which was a German airship, was over visiting the United States. During that time, Hitler, of course, was in power, and he was kind of showing off a lot of the things that he had done in Germany. And the Hindenburg was one of those things. Now, there's a lot of, they're not exactly sure what caused the fire. Some believe it might have been a static buildup that would have created a spark, and then that spark would have ignited the hydrogen. But basically what it did is it ignited the hydrogen gas, which then exploded the airship. And as you can see from the footage we have, that it was an absolute disaster, and it killed everybody on board. Thank you guys for joining us this episode of Science Corner. We look forward to doing more experiments with you throughout the year. For Imagination Station, I'm Justin White.